Hey there everyone, welcome back to another video. Today we'll be looking at IGCSE Chemistry, and in that we'll be looking at experimental techniques. Let's start. Measurement and purity. Measurement, we have time, temperature, mass and volume. Time can be measured using a stopwatch or a stopwatch, which are usually accurate to one or two decimal places. The units of time normally used are seconds or minutes, although other units may be used for extremely slow reactions. Example, roasting. 1 minute is 60 seconds. Temperature is measured using a thermometer, which can normally give readings to the nearest degree. Digital thermometers are available which are more accurate. The units of temperature are degrees Celsius. Mass is measured using a digital balance, which gives readings to two decimal places. These may be set to zero before use. The standard unit of mass is kilogram, but in chemistry, grams are most often used. 1 kilogram is 1,000 grams. Volume for liquids. The volume of a liquid can be determined using several types of apparatus, depending on the level of accuracy needed. The approximate volumes where accuracy isn't an important factor, measuring cylinders are used. These are graduated, have a scale so can be used to measure, and are available in 25 cm cube, 50 cm cube, 100 cm cube, and 250 cm cube. Pipettes are the most accurate way of measuring a fixed volume of liquid, usually 10 cm cube or 25 cm cube. Burettes are the most accurate way of measuring a variable volume of liquid between 0 centimeter cube and 50 centimeter cube. Example in the titration. So over here, this is what a burette looks like. This is what a conical flask looks like. This is what a pipette looks like, and this is what a one volumetric bulb pipette looks like. Let's look at volume of gases. The volume of a gas sometimes needs to be measured and is done by collecting in a graduated measuring apparatus. A gas syringe is usually the apparatus used. A graduated cylinder inverted in water may also be used, provided the gas is in water soluble. If the gas happens to be heavier than air and is colored, the cylinder can be used upright. So this is our reaction mixture, the conical flask and the gas syringe. As the gas moves up, the syringe pushes back, and then the volume could be measured. Moving on, criteria of purity. Purity of a substance. How do you determine whether there are impurities in a substance? It has a higher boiling point. It has a lower melting point. It boils over a range of temperature, as in evaporate. The substance forms more than one spot on the chromatograph. An unknown pure substance can be identified by comparing its melting point and boiling point and comparing to data tables. Why is knowing the purity of a substance so important? In drugs, certain substances have to be pure or they will not take effect, thereby causing doctors to be unable to give effective medication to patients. In foodstuffs, certain substances cannot be put into the foodstuff, or the foodstuff might become harmful to the body. This might cause illness or death. Therefore, it is important that the purity of a substance is tested carefully and accurately. Methods of purification. Purification is the physical separation of a chemical substance of interest from the foreign or contaminating substances. Pure substances and impurities. A pure substance is a substance that has no particles or any other substance mixed in it. An unwanted substance mixed with a wanted substance is called an impurity. To check if a substance is pure, you have to check its boiling point and melting point, then compare to data tables. To check if a pure solid substance has a definite sharp melting point. When a substance is impure, the the melting point falls and its boiling point rises. So the more impurity present, the wider and bigger the challenge in melting and boiling point. The first purification we'll look at is paper chromatography. This is a technique used to separate substances that have different solubilities in a given solvent. Example, different colored inks that have been mixed to make black ink. It is a method used to separate the distinguish and distinguish the substances within a mixture. It is used to separate the coloring agents and dye in products like food and ink. Used to separate different amino acids. Consists of a stationary phase, a floater, and a mobile phase, a liquid. The mobile phase of the liquid flows through the stationary phase of the filter and carries the components of the mixture with it. Different components travel at different rates. In paper chromatography, the stationary phase is very absorbent paper. The mobile phase is a suitable liquid solvent or mixtures of solvent. Performing a chromatographic experiment is basically a three-step process. Application of the process, developing the chromatogram by allowing the mobile phase to move up the paper by capillary action, calculating RF values, and making conclusions. So how does this work? In the ascending method, the bottom edge of the paper is in contact with the solvent and is drawn up by capillary action. A pencil is drawn on chromatography paper and spots of the sample are placed on it. Pencil is used for this as ink runs into the chromatogram along with the samples. Now this is something you have to take note of. Sorry, let me change the color. Due to a lot of questions come on this, why the pencil used when doing chromatography, or why isn't a pen used? That is why I have to pay special attention to this. And also this topic, it usually comes in alternative particles, so you have to pay special attention to this one as well. The paper is then lowered into the solvent container, making sure that the pencil line sits above the level of the solvent so the samples don't wash into the solvent container. Yes, remember this. The solvent travels up the paper by capillary action, taking some of the colored substances with it. Different substances have different solubility, so will travel at different rates, causing the substances to spread apart. These substances with higher solubility will travel further than the others. Paper chromatography. This will show the different components of the ink or dye. First set of the chromatography paper is shown. This is the chromatography paper. The black ink tested substance to be tested, reference material, and the line drawn in pencil. Then you lower the paper into a beaker with appropriate solvent. Wait for the solvent to travel up the paper. The travels up. Then you analyze the chromatogram. Okay, so black has red, yellow, and blue. Red is red, blue is blue, and yellow is yellow. So we can conclude that black is made using the mixture of red, yellow, and blue. Interpret simple chromatograms. If two or more substances are the same, they'll produce identical chromatograms. If the substance is a mixture, it will separate on the paper to show the different components are separate spots. An impure substance will show up more than one spot. A pure substance should only show up with one spot. Moving on, retention factor, also written as RF, may be defined as the ratio of the distance traveled by the substance to the distance traveled by the solvent. It is to determine how far the substance moved in the solvent. So it is the distance traveled by the spot all over the distance traveled by the solvent. So we have to calculate the distance from the baseline all the way to where the solvent goes and mark that, let's say A. Then let's say the spot goes from here to here. So you mark here. Using a ruler, you find the exact values. Then what you do is the value of, let's say this is B, of B all over A is what you'll get what your RF will be. And an RF will always be less, RF will always be less than 1. Okay, let's move on. This value is always less than 1 because the distance traveled by the solvent is always larger than the distance traveled by the spot. Each substance has a different RF value. RF values are usually expressed as a fraction of two decimals. For example, if a compound travels 2.1 centimeters and the solvent travels 2.8 centimeters, 2.1 over 2.8, 0.7, less than 1. Makes sense? Let's move on. Here this is a one RF, so you can find the RF of A, B, C, and M, and then A, B, C, and then find the components. Let's move on. If a substance gives only one spot, this means it is pure because it contains one substance. If two spots that have the same RF value, they are made of the same substance. Locating agent is a substance or liquid that helps to analyze colorless substances in chromatography by reacting with the colorless substance to form colored spots on the chromatograph. For chromatography to be useful, the chemist needs to be able to see the components move up the paper, which is not the case for invisible samples such as proteins. In such cases, locating agents can be used to react with the sample and produce and the colored product which is then visible. The chromatogram is treated with the agent after the chromatography run has been carried out, making the sample run visible to the naked eye. Examples: ninhydrin, anisolarhydral, and UV light. Sorry for the mispronunciation. Uses of chromatography: separate and determine the number of components in a sample, identify colored and colorless components in a sample, determine the purity of a sample, and separate components of amino acids. Let's move on. Mixtures. Mixtures is a physical combination of two or more substances that can be separated by physical means. Examples are smoke, salt solution, sugar solution, toothpaste, paints, and perfume. Properties of mixture: they are not changed by being mixed together. The specific property of each substance is retained. Its components are easily separated. Let's move on. The distribution of the substance in the mixture can either be heterogeneous or homogeneous. Heterogeneous mixtures are those where the substances are not distributed evenly. They have visible different parts. They usually involve a mixture of a solid in a solid. A mixture of tones in a soil is an example of heterogeneous mixture. Homogeneous mixtures are those where the materials are evenly distributed throughout. They don't have visible different parts. For example, seawater. So, examples of some mixture and their components or constituents are: air is made of oxygen, nitrogen, carbon dioxide. Rare inert gas is water vapor. Soil is made from sand, clay, air, water, mineral salts, and living organisms. And such of these are given down below. Let's move on. We have types of mixtures: a solid and a solid mixture, which is formed from the combination of solid substances. This is the constitutes are solid in nature. Examples are a mixture of garri and beans, a mixture of iron filings and sand, steel, brass, and other metal alloys. Liquid-liquid mixture. So it is a mixture which is formed from two or more liquid substances. For example, a mixture of water and alcohol in a uniform mixture is a uniform mixture. Liquids that mix completely and form a homogeneous liquid. Liquid mixtures are called miscible liquids. Example: mixture of petrol and kerosene. Liquids which do not mix completely and so form a heterogeneous liquid. They are called immiscible liquids. Example: kerosene and water, water and oil, and vinegar and oil. A gas-liquid mixture. A type of mixture formed from the combination of a gaseous substance and a liquid. For example, chlorine gas dissolves in water to kill germs in water. Oxygen dissolves in water for aquatic organisms to respire. CO2 dissolves in club soda for the products of fizzy drinks. A gas-gas mixture. Mixture formed with the combination of two gaseous substances. Example: air is a mixture of nitrogen, oxygen, carbon dioxide, and rare inert gases and water vapor. Solid gas mixture. So mixture which is formed from the combination of a gas and a solid substance. Example: smoke, dust particles, etc. Dust is a mixture of very fine particles suspended in the air. A solid and liquid mixture. It is a mixture which is formed from the combination of a solid substance and a liquid substance. A solid-liquid mixture may form a solution or a solid liquid suspension. Example: mixture of salts and water. A mixture of chalk particles and water. Solutions. Okay, so that'll be all for this video. The next part of this video will soon be coming. As you can see, we are done with 9 pages. The rest will be coming soon, so stay tuned for that. Thank you.